What's up, guys? So the other day I got a comment saying I should make zero-tick RAM. So a few days ago I did post a video where I combined, normal RAM and connected it with zero-tick redstone to make it very fast. Took around a second to read or write. Now what I've made here is I've made truly zero-tick RAM made out of zero-tick logic gates. So I'll just do a little demo here. I can give it an input. I can choose a memory cell. So there's only 8 memory cells in this. There's only 8 bytes in this huge, I don't even know what you want to call this, module. So I can set. And if I were to freeze the game and enable this, let me skip a tick. There we go. So it instantly enables, or I guess technically it takes 1 game tick to enable. But I'm going to kind of show how I made this, what kind of logic goes into this, and comparing it to normal redstone and showing how much easier it is to make normal memory. So right here I have 3 different circuits, but they all do the same thing. They store a single bit of memory. So they have a data bit, and they have a set bit. So whenever the set bit is on, it will allow me to set the data, the saved bit with my data bit. So right now nothing is happening. No data can get through. No bit could be saved. But if we turn on our set bit, we can now set what the saved bit can be, and then when I turn it off, I can't change it anymore. So with 1 bit, this is kind of useless, but you can stack these to store multiple bytes and stack those to store dozens of bytes together. And that's how I made my 128 bytes of RAM, by just stacking a lot of these together. This is all possible because of the feature in Minecraft where if a powered repeater is going to the side of another repeater, it locks it. So no signal can go through, and any signal that was in it is now saved. So this actually greatly simplifies making memory in Minecraft. Now this is one example of making memory. I think there's a few ways to make memory, but this is made out of 4 NAND gates, which are basically just have the reversed output of an AND gate. And this does the same thing. So nothing can get in, but as soon as I turn on my set bit, the data can get through, and I can set it. So this does, notice there's a little bit more delay just because of the amount of torches. Now this looks really gross, but it's just the outputs are feeding into the inputs of the one next to it. So that way it can kind of make a flipping circuit. Now here is basically the same thing as this, and I guess technically that, but this is instant. So it uses 4 NAND gates, but it's instant. So then I can set memory like this, and now I can't change it. So I can stack a lot of these together to create my RAM module. And then the final part of this is the 3 NOT gates, and this is just an AND gate, really. So if I just let me just break these inputs real quick. So I can I can put a 1 0 in, I can put a 0 1 in, but nothing will happen. I have to put a 1 1 in for it to output. Now, why I have an AND gate here is for my display. So whenever I have a bit stored in here, for example, I have the top bit and bottom bit here, right, nothing's coming out, right, because this side is off. So whenever I want to enable a certain byte, I power this entire line. So if I were to power this entire line, it turns on the second bit. So if there was a bit stored there, it allows it to come out, and if there wasn't a bit stored there, it will still output a 0, because again, both need to be turned on. So that's kind of how I can make an enabling mechanism, which again is much easier in normal Minecraft. So here is what this AND gate would look like normally. It's just 3 torches instead of those 3 zero-tick NOT gates. So this would be my, if this is my bit stored, nothing's coming out, but I need to send it the signal to the display signal would be just the other bit. And so if there was a 1 stored, then it would output a 1. If there was a 0 stored, it would output a 0. Now, what I would normally do is instead of using an AND gate, I would use a comparator. And comparators are very similar to repeaters, but if there is a, so they don't, like when they're locked, there's nothing going through. But if you unlock them, it allows stuff going through, but when you turn it back off again or lock it again, it doesn't save the signal, it turns it off. So this way I can enable or disable a signal, so I can allow it to go through or I can not allow it to go through. So by combining those, I can basically just make a giant zero-tick memory module. Now the main issue I ran into was, how do I pick which memory slot? Like, how do I pick what memory cell to pick from? And this is where I needed to build a zero-tick decoder. Now, a zero-tick decoder is really simple. It's just an AND gate with multiple input, more than 2 inputs. And so I would adjust the input, so I'd either choose to NOT them or not NOT them, and put them into an AND gate. Now, for example, this is just a 0, 0, 0. So if I want, if I want that bit to be off, for example, it's 0, 0, 0, I will just have, these are just normal zero-tick repeaters, and then I would have my knotted output. Now, if I wanted to have a different input, for example, 4, which is 1, 0, 0, wherever my 1 is, I would have a NOT gate, and then wherever my zeros are, I would just have a normal repeater. So that, if I get out of here, when I put a 4 in, you can see that the repeaters remain off, and then the NOT gate reverses the signal so that we get a 1 output, an output of 1. And then I had then I could choose my set and enable, and it basically just went through another series of AND gates. Just instead of it being for my output, it's for either set or enable. And so combining all those together, I can make a zero-tick RAM module. One issue I found is that when I want to switch memory cells, so for example, if I'm outputting a memory cell, and instead of, if I'm enabling 0, and then I want to switch to another memory cell, you saw it was it briefly turns off and on, which is, I think, an issue with the zero-tick repeaters having the pistons in them having to reset. So I don't know if there's anything I can do about that. But the setting and enabling one memory module takes 0 tick, 1 tick really. But yeah, so that's my 0 tick RAM. It's takes up a lot more space than it needs to. So I'm most likely not going to use this in my CPU. I'm just going to be using my normal RAM module, but I thought this would be a cool video to make, just showing how you would make a zero-tick RAM module. But for now, that's about it. Peace.